Hello students, let's continue our discussion in computer organization. In this video, let us discuss about the memory operation. Two basic operations on the memory can be performed. They are, one is load operation, other one is the store operation. So what is load and store? Load is called as read operation or fetch operation as well, and store stands for write. So this is what the general scenario where we can perform the read operation as well as write operation over the memory. Okay, see here. So this line I am highlighting. Load and store operation are the two basic operations that are performed on the memory. Very important topic. Okay. The load operation transfer a copy of content of a specific memory location to the processor. It copies the data. Where load performs, it copies the data. Memory contents remain unchanged. So steps that are involved in the load operation. The steps for load operation, there are 4 steps involved in case of load operation or read operation. The first one is processor sends the address of desired location to the memory. So from where the data is to be read, this question comes, right? Processor sends the address of desired location to the memory is the first step. It issues a read command or read signal to fetch the data which is to be read. Then memory reads the data stored at the address, and memory sends the read data to the processor, read data to the processor. So these are the 4 steps involved to perform the read operation. So first step is what? You have to processor need to identify the location, memory location. As I said earlier, addressing is important because each and every byte is addressable. So that address value is sent. The processor sends the address of the desired location to the memory. Then processor issues a read signal. It issues a read signal to memory to fetch the data. Then memory reads the data stored at the particular location and it will be sent to processor. That's it. Very simple thing. Next is the store operation. Store stands for write operation. Okay. The store operation which transfer the information from processor register to the specified memory location. Storing means what? The processor data is to be kept somewhere. The data is with whom now? Data is normally with this time. So this time in the sense the processor data need to be stored, isn't it? So the processed data, normally it is with processor. Data, processed data, the manipulated data, right? Computed data, where it is? It is there in the processor register. Where it is to be transferred? It is to be transferred to the memory location. So storing the data from processor to memory, that's what store operation is. So store operation transfer the information from processor register to the specified location, memory location. Okay, this will destroy the original content of that memory location. New data will be kept in the same location. The original contents will be discarded automatically. So these are the two important steps, important things you need to learn: load operation and store operation. So there are 3 steps that involved under store operation. What are those 3? See here. The first step is processor sends the data. See here, the steps for store operations are as follows. The first one, what is the first one? First one is processor sends the address of the memory location where it wants to store the data. Obviously, where the data should be stored, you need to identify the location, isn't it? Suppose if you are sitting in a classroom, you need to identify the desk, isn't it? Where to sit? Yes or no? Assume in place of data, just correlate yourself. Okay, yourself sitting on a particular desk, right? You, before sitting, what you will do? The desk will remain empty, right? And you are identifying if there are multiple disks available, you will identify where to sit. That is what locating. Processor sends the address of the memory location where it wants to store the data. That job is done by your brain, in the sense the job is done by here in the processor. Processor, second step is processor issues a write signal to the memory to store the data. Right? Processor issues a write signal. Earlier it was a read signal, isn't it? Now it is write signal. Now content of register MDR, memory data register content. Normally it holds the data which is to be uh, permanently stored on memory location. So data will be transferred from MDR. Just recall, if you don't know MDR, if you forget, but if you have forgotten what is MDR, just recall. Watch my previous videos, right? Relationship between processor and memory. I clearly told you the different types of registers available in the processor. So one MDR is one among them. So contents of register MDR is written onto the specified memory location. So these are the three important steps it follows to perform the write operation. Okay, very important thing. Load operation and store operation steps. Moving on to the next topics, instruction and instruction sequencing. The computer must have instructions capable of performing the following four basic set of types of operation. Very important topic from the examination point of view. So many times the question has been asked, instruction and instruction sequencing, direct question, or what is the use of instruction, or the question can be like, uh, what are the basic operations that are performed by the instructions. So these are all the common set of questions you can expect, and if you observe the previous year paper, might be the schemes change like 17 or 16, whatever it may be, sorry, 17 or 15 scheme, whatever it may be, but the syllabus was same. And so many times the question has been asked. Okay, there are four types of operations an instruction capable of performing. The four types of operations are, first one is data transfer operation, second one is ALU or arithmetic and logical operations, then program sequencing and control, the third type, and the fourth type is input output transfer. So in case of data transfer, data transferring is normally done between the memory and processor register. It is done between memory and processor register. Okay, data transferring, because memory is separate module, processor registers, they are comes under processor module. So data transferring between them is called as the data transfer operation. So common instructions move, MOV or MOVE, both are valid. Push, pop, the stack operations, we'll be discussing about this later. Similarly, we have arithmetic and logical operations on the data. So there are around 16 types. Okay, or most of the machines and most of the machine architecture. This type of this set of instructions are available, which are capable of performing arithmetic and logical operations on the data. They are addition, subtraction, multiplication, division, XOR operation, not operation, whatever the yeah, these are all the various types of operations like add, sub, MUL, div, and, or, not. These are all the various set of instructions available to perform such task. Then we have program sequencing and control. Program sequencing and control in the sense changing the path of the execution. That even those set of instructions are available like call instruction, return instruction, loop, and interrupt. So these are all the various instructions available. We'll be discussing them in detail later. As well as we have data in and data out, or in or out instructions like input for input and output transfers. These are all the four basic set of instructions available, or in other words you can say an instruction is capable of performing four basic types of tasks. That categories are listed here along with example. The next concept is about the register transfer notation, or RTN it is called as. So what is register? The simplest memory element the simplest element or smallest element of the processor that is capable of holding certain amount of data, which is called as register. So register transfer location. Say R stands for register here. LOC, say the statement which I am highlighting. Content from the memory location. What is this LOC stands for? LOC stands for memory location. Okay. Certain contents are available at memory location. What is the name of the location? LOC. Let LOC is a location, memory location, which is holding an integer value, say 10. Hope this thing is visible. So the meaning of this statement, see, which I am highlighting, stands for access the content from the memory location. What is the memory location? Access the content. See, bracket stands for access its content. So what is the content of location? Content of location is what? Integer value 10. So where it is to be transferred? Check the arrow mark. It is to be transferred to register R. Okay, this is what memory transfer or register transfer notation is. Similarly, one more example for RTN is given here. R1 and R2 register contents. Let R1, R2 and R3 be the three different register. Let it be R1, R2 and R3. I name them R1. Watch carefully. R2 and R3 are the three different registers available, right? So once again, bracket stands for access its content. Let R1 contains 10, R2 contains 20. Please try to understand. Content of R1 is what? Integer value 10. Content of R2 is integer value 20. So what does this stands for then? Access the content from R1. What? Once you access the content, bracket stands for access its content. Once you access its content, which value you will get? You will get 10. In addition with access the content from what? R2, right? R1 and R2. So R1 content is what? 10. In addition with content of R2 is what? 20. So 10 plus 20. What is the summation value? You will be getting 30. So 10 plus 20, 20. That 30 will be kept on where? It will be kept on the register, or it is stored in a register R3. Okay. This is what the RTN is. Accessing the content from a memory location and addition. These are all the various examples. Please note down all these things. Very, very important topic. I shall share the notes, this material in the group as well. Okay. Please pause the video. Note down the content. Next is the assembly language notation. We'll see that in the next session. If you have any doubt, feel free to ask. Thanks for watching. See you in my next video.